Been 18 months in the making, and Conrail has purchased 28 of these locomotives. After watching this video, I feel confident that you will agree the EMD SD80MAC will enhance the performance of our company and reinforce our commitment to you to ensure the safest possible working conditions. Please feel free to send any comments you may have concerning the new locomotive and the EL106 to the address displayed at the end of your video.
The locomotive, symbol of a powerful industry and a growing country. It moved this nation. Although its purpose has remained unchanged for 165 years, the way it accomplished that purpose has been under continual change. Gradually increasing in size and power, the steam locomotive was king until the 1950s, when diesel-electric technology revolutionized locomotives. Today, new technology is again poised to revolutionize the locomotive: AC traction. During 1996, Conrail will be taking delivery of 28 of Electromotive Division's SD80MAC locomotives. The SD80MAC, or 80MAC, is one of the most powerful and advanced locomotives available today. It is powered by an electronically fuel-injected 5,000 horsepower, 20-cylinder, 2-cycle diesel engine. The locomotive is equipped with an air-conditioned whisper cab, a desktop control stand with integrated cab electronic displays, and electronic air brake equipment. The most notable features of this new locomotive are the self-steering radial trucks and a new proven AC traction system. In this video, we'll show you some of the differences with this locomotive, comparing it with an SD60i. We'll review some important safety considerations and cover the new features, performance characteristics, inspection, and troubleshooting procedures you need to be familiar with. Because of the greater capabilities of this locomotive, there are also some important train handling considerations we need to cover. So, let's take a look. Well, here it is, the latest and greatest from EMD. Aside from the new paint scheme, from this view, it looks pretty much like one of our SD60i locomotives. But let's take a walk to the side and take a look. Now you can see some of the differences. First of all, the SD80MAC is longer than an SD60. The 80MAC is 80 feet long. The SD60 is 72 feet long. The SD80MAC is the largest locomotive in our fleet. Here's another difference. The dynamic brake grids are right behind the cab on the SD60i. They have been moved to the rear of the locomotive on the 80MAC. This allows better airflow to the grids and moves a source of noise away from the crew cab, improving the quietness of the whisper cab. The 80MAC has larger radiators than the SD60 to accommodate the cooling needs of the 20-cylinder diesel engine. The fuel tank on the 80MAC holds 5,800 gallons. The SD60 holds 5,000 gallons. Both number 1 and number 2 main reservoirs are on the right side of the 80MAC, while on the SD60, the number 1 is on the left side and the number 2 is on the right side. Now, here's a major difference between the two locomotives, the trucks. The SD60i is equipped with standard HTC trucks and 40-inch wheels. The SD80MAC is equipped with HTC R2 self-steering radial trucks and 45-inch wheels. One of the most revolutionary features of this new locomotive, this truck design greatly improves weight distribution to the axles. It also allows the front and rear axle to steer when in curves. This reduces wheel flange wear and greatly improves adhesion. Let's take a closer look. Again, we'll use our SD60i comparison to highlight the advanced features of this truck. On the standard HTC trucks found on the SD60, weight is transferred from the locomotive frame to the truck, through the center plate, to the truck bolster, and then to the truck frame and to the axles. Because the weight of the locomotive is concentrated on the center plate, when tractive force is applied to the truck, a weight transfer takes place, much like what happens to your car when you push hard on the accelerator. The front goes up and the back goes down. This tipping of the truck will shift the axle loads, putting more weight over the trailing axle and less weight over the leading axle. Since adhesion is directly dependent on weight over the axle, the lead axle is more susceptible to wheel slip than the other axles. This weight transfer is not something you can see on a locomotive truck, but it does take place, and it can cause a wheel slip problem on the lead axle of the truck when high power is applied. Now let's take a look at the SD80MAC's HTCR2 truck. The HTCR2 doesn't have a center plate or a truck bolster. It's equipped with a center pivot pin, which is used to transfer tractive force and bears no real weight. The weight of the locomotive is transferred directly to the truck frame through 4 rubber compression springs. This spreads the weight more evenly throughout the truck and reduces weight transfer, which greatly improves adhesion. Another important feature of this truck, and a major difference from the SD60i's HTC truck, is the HTCR2's ability to steer or realign its axles in curves. Let's take a look. When an HTC truck enters a curve, because of its rigid axles, a high angle of attack exists between the wheels and the rail of the leading and trailing axles. This high angle of attack causes the wheels to have a greater tendency to slip and also produces greater lateral loading on the rails. When the HTCR2 truck enters a curve, a self-steering mechanism within the truck realigns the leading and trailing axles with the curve. This produces a radial alignment of the axles, which reduces wheel and rail wear and also lowers rolling resistance. Now, here's something that's brand new. An electric motor-driven parking brake. No more handbrake. Mounted on the left side of the front truck is a small DC electric motor. It drives a screw jack that will apply or release the brake shoes on the left number 2 and number 3 wheels. The electric parking brake is operated using a switch located on the engine control panel inside the cab of the locomotive. In the event the locomotive is dead and battery current is not available, the parking brake can be applied manually on the ground by using a cranking tool, which will be stored on the locomotive. Another important feature housed on the trucks is the flange lubrication system. The systems are identical on the SD60 and the SD80MAC. The flange lubrication system is designed to reduce curve resistance, saving fuel, and reducing wheel flange and rail wear. This feature, working together with the radial truck, makes the SD80MAC one of the most fuel-efficient locomotives in our fleet. The HTCR2 truck lacks the center plate, truck bolster, side bearings, pedestals, and pedestal liners found on older HTC trucks, but does have additional components, such as traction rods, steering beams, and steering linkage. These components are readily visible from the ground and should be inspected during the locomotive's daily inspection. Now let's take a look at one of the most important new advances of the SD80MAC, the AC traction system.